in this video we're going to be looking at the effect of search costs. So it might be that a consumer does not know all the prices of all the firms until they go out and search, that is, until they go out and find what are the prices. So as an example, here we have a picture of various gas and electric companies, and it could be hard to find out the prices of these firms and compare them. So what effect does imperfect information about prices have on the equilibrium price? So we're going to consider the standard Bertrand model and introduce search costs. So consumers know only the prices of the stores they visit. Each consumer starts at one store and learns the price of that store for free. In order to find out the price set by another store, a consumer must visit that store, and this incurs a search cost S. So the first thing we're going to show is that the introduction of imperfect information and these search costs is going to mean that it is no longer an equilibrium for both firms to price at marginal cost. So we're going to show that there's a profitable deviation. So at these prices, firms are earning zero profits. Let's think about A. What if A raises her price slightly? So if A raises her price so that her price is less than firm B's price of C plus the search cost, then what's going to happen? Well, those who visit A first are not going to visit B because they know the least they can pay at B is C, because firm B is not going to price below C, and they also incur a search cost S. So effectively, they're paying at least C plus S if they buy from B. Now this means that those who visit A, some of them at least, are going to purchase from A, and so A is going to make a positive profit because they're pricing above marginal cost. So there's this incentive to raise price above marginal cost, because even if a firm's price is a bit above marginal cost and a bit above the other firm, it's going to cost S to go and actually find out. So even though firm A is pricing above marginal cost, a consumer is not going to go to firm B because they know it's going to incur a search cost, and if A's price is not too much above marginal cost, they know they can't be better off by going to B. What is the Nash equilibrium? Well, now we're going to show that when the search cost is positive, it's an equilibrium for both firms to price at the monopoly level. So here we're going to assume, as we did with the model with switching costs, that each consumer is willing to pay up to V. If the price is less than the V, they buy a unit, otherwise they don't. And one thing to stress here is that in contrast to the case with switching costs, we're not assuming that the search cost is above some value, we're just assuming that it's positive. The other thing here we have to take account of is that there's imperfect information in this game. So in describing the Nash equilibrium, we also need to describe the beliefs of the consumers. In this equilibrium, the prices are equal to V, and all consumers believe that any store they will visit will offer this price. So the consumers' beliefs are consistent with the prices chosen by the firms. So in the proof, we'll, as usual, show that a firm has no profitable deviation. So let's think about firm A. What if she raises her price? So now her price is above V. Well, then she'll get no demand because no one is willing to pay more than V. So her profit would be zero. This profit is obviously less than half the monopoly profit. Now suppose A lowers her price. Is this going to attract any consumers away from B? Well, no, because those consumers who visit B first are not also going to visit A, and therefore they're not going to observe A's price cut. The reason they won't visit A is they expect every firm to be pricing at V, so there's no reason to visit A. So what we've got is that for any level of search costs, no matter how small, we get monopoly pricing. So as soon as we introduce imperfect information and these search costs into the Bertrand model, we go from pricing at marginal cost to pricing at the monopoly level. So this result is known as the diamond paradox. Just be careful here, there's another thing called the diamond paradox with a small d. This is with a big D named after an economist with the last name Diamond. So the Diamond paradox is that we have this knife edge result. The tiniest search cost breaks the marginal cost pricing equilibrium and gives us an equilibrium at the other extreme, monopoly pricing. So to summarize, when search costs are introduced into the Bertrand model, for any level of search costs, it's no longer an equilibrium to price at marginal cost. And for any positive search costs, no matter how small, it's an equilibrium for firms to price at the monopoly level. So what are the implications of this result? Well, it implies that search costs give firms monopoly power. So again, there's a place for government intervention. And in the case of gas and electricity, they have websites that allow you to easily compare the prices of different gas and electricity suppliers. So these comparison websites reduce the search costs and therefore might have some effect at reducing monopoly power.